Welcome to GC Engineering and Technical Drawing. Today we'll be drawing an helicopter using the principle of tangency. So start by drawing a straight horizontal line. So succeeded in drawing a straight horizontal line. Then from our diagram, we'll also draw a vertical line. So succeeded in drawing a vertical line, and from our diagram, we'll call this a vertical line at this point here, point B. So represent it also here as point B. Now from point B towards our left hand side, so should measure 67 millimeter. Then we indicate with the point, and then we'll project our points upward a little, and then also from here, so should measure 29 millimeter towards our right. So pick 29 millimeter towards our right, and then we project also upward. Now from our points, our 2 points here, point A and point B, we are told that we have a wheel which diameter is 13 millimeter. So our radius is going to be half of 13, which is going to be 6.5. Taking 6.5 millimeter with our compass, place it at point B, scribe an arc, and then using the points on a vertical line, we'll draw a circle. We'll do same to point A, scribe an arc, using the points on a vertical line, a circle. And then from our diagram, we are told that the total height from our ground, this is our floor, from our floor to the base of our helicopter is given to us as 19 millimeter. So we'll measure 19 millimeter upward from our vertical line, and we indicate with a point. We project our points with a construction line. Now from the diagram, you observe that from our first wheel at point A, we're told to measure 16 millimeter upward. So measure 16 millimeter upward, and then we'll indicate with the point. So succeeded with indicate with a point. We'll project the point to a construction line, and then we're told that the total thickness close to the wheel at point A is given to us as 6 millimeter. So we'll measure 3 millimeter to our left, 3 millimeter to our right, project the point upward to hit our baseline, and then we can outline this and this. Now from the diagram, we are told that our stud, all stud is given to us as 3 mm wide. So from our first wheel at point A, we'll pick 1.5 mm to our right and 1.5 mm to our left. Then we'll project the point downward to hit tire of our helicopter. Over here you can see the position here. Also at point B, we are told that each stud here is 3 mm wide, so we'll have a stud going up and a stud at angle 45 degree. So from the wheel of our helicopter, we'll measure 45 degree using 45 degree set square, and then we'll project till it hits the base of our helicopter. And then we are told that at 45 degree the stud is 3 mm wide, so we'll place our 45 degree set square also this way, and then we'll measure 1.5 mm to our left, 1.5 mm to our right. And then still using 45 degree set square, we'll project you can see. Also we'll do that upward. We'll measure 1.5 mm to our left and 1.5 mm to our right. And then we'll project upward to hit the base of so succeeded in getting that. Now we can now outline our base of our helicopter this way. Now we'll take our set square and project a vertical line of our choice at any point of our choice, just for scaling. And then from our diagram, so we should measure 48. We want to get this curve here so that we can join these together. So we should measure 48 mm upward from our vertical line. We take 48 mm, indicate with the point, and then we draw a light horizontal line and then from our diagram you can see that from the center of our vertical center line to the tip of the helicopter is given to us as 111 mm. So we'll measure 111 millimeter from point B towards our left, 111 millimeter, indicated the point, and then we'll project upward with the construction line. Now you can see that this point here, should they intersect, you can call this point 0. Now using point 0, we'll open our compass to 13 millimeter radius. You can see to 13 millimeter radius. So we succeeded in picking 13 millimeter radius with our compass. We'll place it at point 0 and we'll scribe an arc on our horizontal line. Now using that point on our horizontal line, we'll draw a semicircle. So succeeded in drawing our semicircle. So the next thing we're going to do is that we're going to join this 101 millimeter radius. There's an arc of 101 millimeter radius touching a circle of 13 millimeter radius internally. So when circle touches each other internally, you subtract. So subtract 101 minus 13, which will give us 88 millimeter. So we'll call this point here point 02. Now using point 02, we'll place a compass pin at point 02. Our compass is already open to 88 millimeters radius. Then we'll scribe an arc. Now from our diagram, you can see that this arc here is touching the tip of this portion here. So we'll call this point 03, and then we'll open our compass to 101 millimeter radius. So we succeeded in opening our compass to 101 millimeter radius. Place it at point 03. Then we'll bisect our arc. Now using the same radius of 101 millimeter which we've measured at the point of the intersection. Now at the point of the intersection here, we'll draw an arc touching point 03, and it's also touching the circumference of what our circle. Now the next thing we're going to do from our circle at point 02, we'll project it with a construction line upward. Now from our diagram, so we should measure 22 millimeter from our vertical line upward. So we'll measure 22 millimeter radius, indicated with the point. Then we'll project our point such that it bisects our vertical line of 0.2 millimeter here, which we'll call this point small a. Now using point 0 and point A, so we should get an arc of 51 millimeter radius. So open our compass to 51 millimeter radius. So we succeeded in picking our compass to 51 millimeter radius, which is this. We'll place it at point A, scribe an arc, let it be construction line, and then we'll place it at point 0. We'll bisect the arc. Now using the point of the intersection, you can see they intersected here. Still using radius 51 millimeter. Draw our arc. You can see the arc touches this point 0 to point A, so we can erase this. Now from our diagram, so we should measure 16 millimeter from our vertical line. So we should pick 15 millimeter. So pick 15 millimeter at our horizontal line, indicate with a point, and we'll project our line towards our right. Now such that it hits our vertical line at point 02. Call that point A1. Now from point A1 towards our right, we'll measure 10 millimeter radius, and then we indicate it with the point. 10 millimeter radius, indicate it with the point, which we've done. Now let's say we should join point A, which is this, to the point we just located. Let me call that point A2 to point A2 with a straight line. Then we'll take our rule and we'll join point A2 to point A with a straight line. Which we've done. Now from our diagram, so we should measure 32 millimeter. We should measure 32 millimeter from our center line towards our left. So come to point B. We'll pick 32 millimeter towards our left. We indicate the point, and then we'll project our point upward with a light construction line, which we've done here. You can see from here to here is 32 millimeter. Now from our diagram, see total distance between this point to this point over here is given to us as 10 millimeter. So all we need to do from our vertical line of our left hand side, we'll pick 10 millimeter radius, 10 millimeter, sorry, and then we'll project our point till it cuts, till it bisects a line of 32 millimeter radius, of 32 millimeter, which is this. You can see it cuts through, and we'll call that point B1. And so we should join point A2 and point B1 together. You can see from this point here to this point with a straight line. So take our rule and we'll join points A2 and point B1 together. Now from our diagram, at point B1, which is this, so we should take 45 degree. So we'll pick our set square, place it this way, from point B, we draw a straight line which is 45 degree, which is 45 degree. Now, from our 45 degree, we are told that the total distance on the line we constructed on our 45 degree is 13 millimeter. So pick our rule and we'll measure 13 millimeter on our 45 degree line. Measure 13 millimeter and then we'll outline it. Yes. Now we call this point here point B2. Now from point B, which is this, we're told to open a radius of 105 millimeter to get a curve here. So place our compass pin, open our compass to 105 millimeter radius, place our compass pin at point B, then we'll scribe an arc. Now, from our diagram, we're told that the distance of this point of the arc proceeding from our vertical line towards the left is given to us as 10 millimeter. So what we need to do, we'll project the arc, the construction line, just to pick 10 millimeter radius. Then we'll pick 10 millimeter from our center line. Then we indicate with a point on our arc. You can see it now on our arc. Then where it hits our arc, we'll call that point B3. Then we are free to outline our arc because we now know where now outline that portion. Now using points B2 and point B3, we'll open our compass to 38 millimeter radius. Now using points B2, B3, we've opened our compass to 38 millimeter radius. This is it from our diagram. B2 and B3 having a radius of 38 millimeter radius here. Place our compass pin at point B2, scribe an arc. Place our compass pin at point B3. We bisect the arc. Now using the point of the intersection, still on radius 38 millimeter, we'll join with our arc. You can see it's touching points B3 and point B2. Now also we'll open our compass to 25 millimeter radius. So succeeded in opening our compass to 25 millimeter radius using point B1 and point B3. Points B1 and point B3 with radius 25 millimeter. Place a compass pin at point B1, scribe an arc. Then we'll place a compass pin at point B3. We'll bisect the arc. Now using the point of the intersection, still on radius 25 millimeter, we'll draw arc. Can see touching that. Now from our diagram, we want to deal with this portion here. So now we want to know how to place the wings of a helicopter. Now from our diagram, you can see that from the ground floor, which is this, to the top of the wing is given to us as 114 millimeter. So pick 114 millimeter, indicate with the point, and then using our points, project a little line, just a little, and from point B to our marked point on our vertical line is given to us as from here to this point here, which is this 114 millimeter. Now we know that the total height of our helicopter wing head here is given to us as 10 millimeter. You can see 10 millimeter. So we'll mark on our line from our marked points. Since the total height is given to us as 10 millimeter, we'll pick 5 millimeter upward, we indicate with a point, and then 5 millimeter downward, indicate it also with a point. Call these points 1 and point 2. Now using point 1, see the curve over here is given to us as radius 38 millimeter. So pick 38 millimeter radius from our rule. 38 millimeter radius. Now place it at point 1. Now describe an arc downward using the points with that bisect the vertical line. We draw an arc. You can see it's touching point 1. Also using point 2, describe an arc, our arc up on a vertical line. Now using the points of the intersection on our vertical line, we draw arc. Now you can see it's passing through point 2. So the next thing I'm going to do, you can see that from the top of the wing, see the total distance from the center line towards our left should measure 13 millimeter, and then 13 millimeter to our right. So come to point B, we'll pick 13 millimeter, indicate with a point. Now using that point that we got, we'll project our line to cut and also measure from point B 14 millimeter to our 13 millimeter to our right. Get to the point, project our points upward to cut our wing head here. You can see that this here touches this perfectly. So if yours is not touching like mine, all you need to do is to go back. You can see, and then increase your arc a little. It's just that the arc was not extended very long. Also use the top side and then increase it a little. So we succeeded in getting the top of our wing. Now you recall that the total height of the wing is given to us as 114 millimeter, which is this our point. So project with the construction line to our right, and then with the construction line to our left. Now, but we're not done with the top, which is this portion here. Now you can see they say the total distance between here to here is given to us as 13 millimeters. So we'll measure 6.5 to our left and 6.5 to our right. 6.5 to our left and then 6.5 to our right. Then we'll project upward with an outline. Project this also up with an outline. And then from our diagram, you can see from this midpoint to this portion here is 32 millimeter, which is from this midpoint to here is 32 millimeter from here you can see, which is this. Now also from this point towards this point here is 32 millimeter, so we'll measure 32 millimeter. Then we'll indicate the point and then we'll outline all through, you can see, and then you can see a curve here of radius 102 millimeter, and this curve stops at where we measure 127 millimeter towards our left. So all what we need to do now is that we'll measure 127 millimeter from our center line. So use point B towards our left. We'll pick 127 and then indicate the point. Now using that point, we'll project that point upward, referring to this distance 127 millimeter. So now from where we outline our 32, which is this, we project that line downward with the construction line, very light, which is this. We open our compass to radius 102 millimeter. So succeeded in picking a radius of 102 millimeter radius. Now on our line which we got downward, placed a compass pin here. I'll scribe an arc downward. You see that they intersect at a point. This is still projecting down at the point here. So now using that point, the point of the intersection, open our compass to 102 millimeter, which we have already done. Then we'll project our arc. Now once it hits the distance of our line of 127 millimeter, which is this, we'll stop. So we're free. So like you can see, so we're done with the left hand side of our diagram. So we're moving to the right hand side. Now from our diagram, we're told we have a horizontal line here which height is 51 millimeter. So come to point B, we'll measure 51 millimeter, indicate with the points on our vertical line. Now using our points, we'll project towards our right You can see. And then we're told that there's a distance here of 20 millimeter. So pick 20 millimeter, indicate it the point, and then we'll project a vertical line there. Now using the point of the intersection, so she open our compass to radius 10 millimeter. So succeed in opening our compass to 10 millimeter radius. Place it at the point of the intersection, and then we'll draw a semicircle. Also from that same portion here, you can see that, so we should measure 22 millimeter towards our right. So pick 22 millimeter, indicate it to the point, and then we'll call that point call this point here point C, call this point C1, call this point C2, and then we'll open our compass. Let's say we have a radius there of 44 millimeter radius, so we'll open our compass to 44 millimeter radius. So let's open our compass to radius 44 millimeter, place our compass pin at point C1, scribe an arc, place our compass pin at point C, we bisect the arc. Using the point of the intersection, we'll draw an arc touching point C and point C1 together. Also, using point C1, scribe an arc. Now using point C2, we bisect the arc. Now using the point of the intersection, scribe an arc touching point C1 and point C2 perfectly. The next part we're going to look at is this. There's a curve here of 19 millimeter radius. Now I'm proceeding from the base. You can see this is the base. So from our base, from point B of our small b of our wheel, you can see from the base, not from the tire, describe an arc upward. Now using that arc, open to radius 19, which we use, the arc should be 19 from here to here is 19 millimeter. Now place a compass pin at our point, then we draw, stay on 19 millimeter radius, draw a curve looking like a circle, not a full, just an arc here, and then we are free to outline this portion here, and then this upward, up. Once it's reached at 19, we stop. And now we're having a curve here of 70 millimeter radius. All we need to do is that bring our set square, place it to touch the circumference of our circle of our radius 19 millimeter. Then we'll project a straight line down, and then we know that the total distance from our center line, the total distance, okay, let me shift it towards this way so you can see. Now the total distance from our center line here to the end of this portion here is given to us as 273 millimeter with a rule from point B. 273 millimeter. This 273 millimeter indicates with the point. You can see over here with the point, and then we'll project upward. We'll project upward the construction line. Now, from our diagram, the 273 millimeter was from point B to this portion here, and we are told that the height from the baseline to this is given to us as 67 millimeter. So measure 67 millimeter from our vertical line from the floor. Measure 67 millimeter, indicate with the point, and we'll call that point x1. And then from our diagram, from point x1, which is this portion here, which is this line here, so we should measure 16 millimeter up to get this distance. You can see, which is this. So measure 16 millimeter upward, indicate with the point, then we'll call that point x2. And also from the top of our helicopter here, there's a point here. Call this point x3. You can see this point here, point x3. Now you can see that there's a straight line joining point x3 to point x2 together. So use our rule and we'll join point x3 and point x2 together. With our outline, we'll draw this. Now, still on the tail of our helicopter, this point x3 is for this portion here. Now from point x3, so we should measure 48, we should measure 10 millimeter towards our left, or towards our right hand part. Now this is it. You can see this our line here. So we should measure 10 millimeter towards our left. So pick 10 millimeter, indicate with the point, and then we'll project the point upward with the construction line straight up. And then we can, from point x1 now, we can indicate, can project point x1 towards this point here. You can see now. Then we'll join points. Let me call this x4. Join point x4 to point x3, point x4 to point x3 with a straight line. Which is this. You succeeded in joining that portion together. Then we can erase this. So the next thing we're going to do, from point X4, project a straight horizontal line. Once it hits a vertical line over here, you know we've got a vertical line over here, we'll call this point here point Y. Now when cycle touches each other externally, we'll add. So you can see this curve. I want to get this curve here. That's what we're doing. We have radius 19 touching radius 70 millimeter externally. We add 19 plus 70 millimeter, which will give us 89 millimeter. So place it from where our 19 millimeter progresses from, which is this point here. Then we'll scribe an arc with radius 89 millimeter. When we added 19 plus 70 millimeter to give us 89 millimeter, we'll scribe an arc. And then we'll open our compass to radius 70 millimeter. So succeeded in opening our compass to 70 millimeter radius. Place it at point Y. Then scribe an arc on a horizontal plane which leads to point X4. Then we'll call the arc here point Y1. Using point Y1, we still at radius 70 millimeter. We'll bisect our arc. I'll call the point of their intersection Y2. Now using the point of the intersection point Y2, our radius still on 70 millimeter. We'll draw an arc. An outline. You can see touching the circumference of the circle of 19 millimeter radius and point Y. Then you can erase this portion a little. Then we can outline points Y1 and point X4, point Y1 and point X4 together. You can see. So succeeded in getting this curve. Now we note that from our diagram here, you can see that from the midpoint, point B, to here was 273 millimeter. So where it hits this line here, we'll measure 57 millimeter towards our left. 57 millimeter to our left. And then we indicate with a point. Then from the point we indicated, we'll outline all through till it hits the fan of, indicating the fan of our helicopter. You can see. Now at that portion here, we'll call this point Z. Now at point Z, we project point Z downward with a construction line. Then we'll stop. Then we'll open our compass to radius 102 millimeter radius. So we succeeded in picking our compass to 102 millimeter radius, place it at point X, scribe an arc down, then it intersects at our vertical line at point X2 using point Z2 still on radius 102 millimeter. We'll draw an arc. Once it hits a horizontal line here, which is touching point X2, which we got as 100 and 273 millimeter distance from our center vertical line. From here, point B to this line here is 273 millimeter. So once it hits that line, it will stop. You can see, outline this. Once it hits, we'll stop, make it an outline, and you see we are done with the wing aspect of our helicopter. Now, if you can recall, from our center line here to this portion which we got to, which is 273 millimeter, was this. So permit me to call this point V here so that we can make use of it. Now from point V, let me erase this so that it can flow together. Now from point V, we are told to measure 79 millimeter. So measure 79 millimeter, indicate the point, and then we'll project upward to construction line. Now we've gotten this portion at 79 millimeter, which is from point V towards this portion here. Now from our diagram, we're told that we have another horizontal plane here of 121 millimeter. So take our rule and I will measure 121 millimeter, 121 millimeter, indicate with a point, and then we'll project our point with a center line which we've done. Call that point 0. Now from point 0, which is this here, point 0, so we should measure 10 millimeter towards our left. So pick 10 millimeter from point 0 to our left, indicate with the point, and then we'll project it with a little mark over here. Now you can see at that point there, they say there's a radius of 3 millimeter radius. So open our compass to 3 millimeter radius. So succeeded in picking our 3 millimeter radius, which is this. So call this point 0.01. Place it at 0.01. Then we'll draw a cycle. It's a very small radius, so draw a semicircle, which is this curve over here. And then we are told that we should measure from point 0 towards our right. We should measure 32 millimeter. So pick 32 millimeter, indicate with the point. Now then we'll mark the point which you project. You just a small mark, which is 32 millimeter. Remember, when radius touches each other internally, we'll subtract. So subtract 3. You can see this curve here is radius 76. So subtract 3 millimeter from 76 millimeter, which will give us 73 millimeter radius. So pick 73 millimeter radius with a compass. So succeeded in picking 73 millimeter radius. Place it at 0.01 here. Scribe an arc, and then we'll open back our radius back to 76 millimeter radius. So succeeded in picking 76 millimeter radius. Place it back at 0.03. We'll bisect the arc. Now using the point of the intersection, scribe an arc. Using the point of the intersection, a radius 76 millimeter will scribe an arc. Yes, we've gotten this curve, which is this. Now when circle touch each other externally, we'll add. So add 3 millimeter radius plus 76 millimeter radius, which will give us 79 millimeter radius. So open a compass to 79 millimeter radius. We've succeeded in picking our compass to 79 millimeter radius at 0.01. Scribe an arc. Can erase this so that not get confused. 0.01. Scribe an arc. Then open back our radius, our compass to 76 millimeter radius. So succeeded in picking 76 millimeter radius. Place it at 0.03. Bisect our arc. Now still using 76 millimeter as radius to the point of the intersection. So place a compass pin at point of the intersection, and then we'll draw arc. And then the next one we're going to do, we're going to join points x4 to point 0, close to the curve of point 0, and also we're going to join point x2 to the circumference of this curve here, to x4, join with a straight line. Then we'll join x2 together, join it up with a straight line. Forgotten this. Now open our compass to get the circle of the fan of the tail of our helicopter. Open our compass to radius 51 millimeter. So succeeded in picking 51 millimeter radius. Place our compass pin at point 0, which is this, and then we'll draw a cycle. Can leave a little bit of broken line, indicate with the broken line, or should I call it the center line? Sorry. Thank you for watching. We've succeeded in drawing a helicopter using the principle of tangency. Don't forget to give me a thumbs up and then subscribe to my channel.